Welcome back to video 4 on vectors in 2 dimensions. We're now going to look a little more at component form of a vector because we introduced it very quickly in the previous video. Let's talk a little bit more about how you can define a component vector. If a vector v is represented in the plane with initial point P, where the point is x sub 1, y sub 1, and terminal point Q, where the point is x sub 2, y sub 2. Then to find the vector in component form, we would say vector v, note it's now as a bold V instead of a V with an arrow across the top. Just notation-wise, they're equivalent but have different uses. So v is equal to the pointy bracket, x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. Notice we're taking the terminal x coordinate and subtracting the initial x coordinate, and likewise with the y's, we're taking the terminal y coordinate and subtracting the initial y coordinate. If we were to draw a picture of this, let's say we have a vector v in the plane that we just drew. It's heading to the top right of the xy axis, where we have our vertical axis y and our horizontal axis x. The initial point is the point x sub 1, y sub 1, and the terminal point is the point x sub 2, y sub 2. If we wanted to identify these coordinate points in the x direction, we would say the initial value is x sub 1 for the x coordinate, and horizontal shift up y sub 1 in the y coordinate direction. And then similarly, if we were to trace the second point both over to the y coordinate, this would be y sub 2, and vertically we would trace this down to the x-axis, this would be x sub 2. And so you can see here how if we find the difference between the x and the y values, we can then determine what its displacement is. We can also list its components. Our x component will be the x sub 2 minus x sub 1. And so the vector v is equal to first component x sub 2 minus x sub 1, and second component vertical direction y sub 2 minus y sub 1. Let's find the component form of vector u with initial point 2, 4 and terminal point negative 1, 1. And then we'll sketch the vector. I start at the origin and count 2 to the right and up 4. And I'll put a point there and label it 2, 4. I will then start at the origin again, count to the left 1 and up 1. Put another dot there, this is my terminal point, and label it as negative 1, 1. I will then take the initial point and go to the terminal point, and that is my vector. If I wanted to list this vector u as a component vector, I could say u is equal to pointy bracket. If I wanted to list the components for this vector u, I would say I have a terminal value of -1 in the x direction, and I will subtract 2 from it. And in the y direction, I have three as well, and it goes down 3. So if I look at the 1 minus 4, I will have my value for the y component. This says that the vector u has components -3, -3. And if you think about this as rise over run, we have a rise of -3 and a run of -3, which makes sense. So that is the component form of vector u. We could also say that this is equivalent to a vector u like that. Notice that one is a bold u, kind of scripty u, and the other one is an italicized u with a vector on top. Now let's look at example 5. If vector w equals 5, 3 in pointy brackets, and its sketch with initial points 1, -2, find its terminal point algebraically as well as geometrically. Let's first sketch 5, 3 with initial point 1, -2. First, I'll find the initial point 1, -2. Then I will count its vector displacement in the x direction and the y direction. The vector is displaced 5 units in the x direction and 3 units in the y direction. And so my terminal point is the point 6, 1. Now you may be wondering, how in the world would I draw this or calculate this algebraically? Let's go ahead and figure that one out next. There's my vector w, and I'm going to now calculate this using the formula. I know that the vector w in component form is x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. If I want the terminal point, I know that the components x sub 2 minus x sub 1 equals 5. And I'm just going to circle that. And I know that y sub 2 minus y sub 1 equals 3 because of the components given. So the vector w will have initial point, which is given, as 1 and -2. And I don't know x sub 2 minus 1, and I don't know y sub 2 minus -2, but I can find them if I know that they equal 5 and they equal 3 respectively. This means that if I want to find x sub 2, that will be 5 plus 1, bringing that -1 over. And if I want to find y sub 2, that will give me, I'll write it out, y sub 2 minus -2 equals 3, which means I'm going to subtract 2 from both sides. That gives me y sub 2 equals 1. So my terminal point algebraically is the point 6, 1.